Hello everyone, so today we're going to calculate the double integral. The body of the integral will be 1 over 1 plus y to the fifth dy times dx. Y is from x to the 1/4 to 1 and x is from 0 to 1. Now we see that it will be quite difficult to do if we're just going to do it with respect to y first because, well, y is from x to the power of 1/4 to 1 and, well, it looks quite difficult. So how about let's change the order of the integration. Now, let's draw the intervals of this integration. We see that y is from x to the power of 1/4 to 1, and x is from 0 to 1. So on a graph, it is actually this red shaded area. We see that it is actually bounded by these curves, y equals to 1, and x equals to 1, and x equals to 0, and y equals to x to the power of 1/4. Now, y equals to x to the power of 1/4. So that means that y to the fourth is equivalent to x. In our original formula, x is bounded by two constants. Now we want to change such that y is bounded by two constants. So we can see that y goes from 0 to 1, and x goes from 0 to y to the fourth, because, well, we see that y is equivalent to x to the power of 1/4. So there we go, we see that we have a new boundary. This is when y is from 0 to 1 and x is from 0 to y to the fourth. So there we can substitute our orders of integration. It becomes the integral of 1 over 1 plus y to the fifth times dx times dy. And x is from 0 to y to the fourth and y is from 0 to 1. Now we evaluate the inner integral and it becomes y to the fourth divided by 1 plus y to the fifth times dy, and y is from 0 to 1. Now let's take a look at this remaining integral. This is, well, quite straightforward. We can imagine y to the fifth plus 1 as a new variable. So the derivative of this new variable would be 1/5 of y to the fourth. So we can see that this is just 1/5 of natural log of 1 plus y to the fifth, and y is from 0 to 1. So substitute these in, we see that the final answer would be 1/5 of natural log of 2. Now, there's a trick to doing this type of problem. We see that if we're going to integrate with respect to y first, it is basically impossible, so we have to change the order of the integration. Now, how do we do this? We observe that the boundaries of the integral is from, y is from x to the 1/4 to 1, and x is from 0 to 1. So it is actually a triangle, and the upper part of this triangle is 1. Now, we can see that in our modified integral where the order is swapped, it is also a triangle right here. It is, in the upper part it is 1, and in the bottom part it is 2 zeros. So, and the only remaining part would be this x to the 1/4. And since this is the boundary for y, so y equals to x to the power of 1/4, so x is equivalent to, well, y to the fourth. So we can just swap that in. And this is a trick when you're dealing with this type of problem. You don't really have to draw a graph to determine the integral of this integration.